Thank you for stopping by and checking out the PolyFew Editor utility. PolyFew is a mesh simplification and automatic LOD generation solution for Unity. It allows you to optimize high-quality 3D models through polygon reduction, representing the same model using fewer polygons with little to no compromise in quality. This can greatly improve the performance of your game. Polygon reduction becomes essential when building complex game environments with lots of polygons to process, especially when developing for resource-constrained platforms like mobile phones or other low-end devices. PolyFew supports simplifying both static and skinned meshes, as well as nested object hierarchies and multiple materials, while giving you different parameters to fine-tune the mesh simplification process. Let's show you how to get started. After importing the package, you'll get a folder named PolyFew in the Assets directory. It's highly advised that you don't modify this folder or its contents in any way. PolyFew requires that the gizmos from the scene view are enabled, and have the transform gizmos checked. Click on the model that you want to simplify or generate LODs for. Clicking on the model reveals the PolyFew inspector window in the components hierarchy. The exact number of triangles in the mesh can be seen from the triangles count field. As the selected object is meshless, so we see 0 triangles. Checking the Reduce Deep option will take into account all the nested meshes under the selected object. The triangles count field now shows the total number of triangles considering the nested meshes as well. The reduction strength slider allows you to adjust the percentage with which the mesh is simplified by. Moving the slider allows us to visualize the changes with the current settings before actually applying them to the model. We can see that we have reduced the polygon count significantly, but now we have got some broken unconnected triangles in the face region. To solve this, we can set different parameters for the simplification process. These parameters allow us to preserve certain triangle groups based on special characteristics and thus fine-tuning the simplification process. The preserve borders will allow us to preserve the triangles forming open borders or contours. Checking this option will solve our problem. Similarly, we have some other options to preserve UV seams and UV foldover regions. It's best that you try out these options to see what works best to your case. The Smart Linking option will link vertices that are too close to each other. This helps in the mesh simplification process where holes and other serious issues could arise. Disabling this can cause a lot of unlinked vertices, causing holes in the mesh. Disabling this in cases where not needed might help you get a slight performance gain. The Aggressiveness and Max Iterations options allow direct control over the simplification algorithm. The default settings work best in most cases and should not be changed. Changing these options can significantly degrade performance of the simplification process. Everything looks great now, but let's say we want to keep the face as it is and not simplify the face region at all. This can be achieved by enabling the tolerance sphere. It allows you to encompass specific areas of the model that you want to ignore during the mesh simplification process, leaving such areas with the original quality. Now that we have submerged the face in the tolerance sphere, we can move the reduction slider a little bit to see the changes in action. We can clearly see that the polygons of the face remain untouched while the rest of the model has been simplified. After finalizing the settings, we can hit the Reduce button to apply the changes to the model. Click the Save button to save the simplified meshes and choose the path where you want to save the meshes. Now save the scene. It's important to note that if you don't save the scene now, you must save it before exiting the Unity editor, otherwise the changes would be lost. We can revert the applied changes from the Undo and Redo buttons. Let's see how we can generate LODs for this model. Select the object and expand the Automatic LOD section by clicking on the Automatic LOD label. We can see various options listed here. The Change Save path will allow you to use a custom path where the generated LOD mesh assets will be saved. By default, there are 3 LOD levels shown, but you can add or remove LOD levels. The Add button allows you to add as many LOD levels as you want. The Cross button removes an LOD level. Let's adjust a few settings and generate LODs for this model. The LOD level 1 corresponds to the highest detailed level or the base detail level, so we won't simplify any meshes in this level. Let's say in level 2 we want to simplify the model by 25%. So we'll move the reduction strength slider to 25%. Expanding the reduction options allow us to see further options for simplifying the meshes for this LOD level. We also want to keep the face untouched for this level, so we'll enable the tolerance sphere and submerge the face in the sphere. Now we'll check the regard tolerance option to take into account the preservation sphere for this specific LOD level. The screen relative height controls how far the viewing camera must be from the object before a transition to the next LOD level is made. After finalizing the settings, we can hit the Generate LODs button and wait for the process to complete. Now save the changes to the scene. And that's all, we're done.